This is review recording 1A and B to accompany instructional recordings 1A and B for Section 9.2, Unit 9, Chapter 9 of Mathematics 2200. We'll be relating the solution of a quadratic inequality in one variable to the graph of the corresponding function and solving a problem that involves a quadratic inequality in one variable. Example 1. The graph of a quadratic function f of x equals ax squared plus bx plus c is shown. Using the graph, which best represents the solution for ax squared plus bx plus c less than 0. Basically what this means is what values of x, if we were to plug them into this unknown function, would return a negative value, because less than 0 means negative. That corresponds to getting negative y values on the graph. So that would be this portion of the graph. Remember, we cannot include the x-intercepts of the graph because that would give us a value of equal to 0. So I've just put circles there to remind me of that. That corresponds to the number line interval that goes between the two x-intercepts, i.e. -3 less than x less than 7. No equal sign there. So that corresponds, because you notice that all these options are in interval notation, that would be the same as option D. Because the rounded brackets here indicate that the -3 and the 7 are not included in the interval. Example 2. A ball thrown into the air follows a path approximated by h of t equals -5t squared plus 25t, where h of t is the height in meters of the ball above ground t seconds after the ball is thrown. Write and solve a quadratic inequality to determine the interval of time the ball is at a height of at least 30 meters. Illustrate your solution interval on the number line. To help us picture this problem, I've sketched the path of the ball, and we're interested in when is the height of the ball above 30 meters. Our horizontal axis represents time, vertical axis represents the height of the ball. So we want to figure out when is -5t squared plus 25t, and it says the ball has to be at a height of at least 30 meters, so it's got to be greater than or equal to 30. It's at least, not less than 30, at least 30. So we do some rearranging here. -5t squared plus 25t has minus the 30, I'll bring that across, that has to be greater than or equal to 0. And to make this easier to solve, I think I'll divide everything by -5. Don't forget though, the moment I do that, I'm going to have to change the direction of my inequality because I divided by a negative value. And don't forget, we have to get the roots of the corresponding equation, which is t squared minus 5t plus 6 equals 0. That will factor as t minus 3, t minus 2 equals 0. So t equals 3 and t equals 2. We mark those roots on the number line. We don't use hollow circles because we have an equal sign in our inequality. Now, because it is an inequality we're trying to solve, we'll need some test values. I've come over to a new slide and I'll create a table here to help us understand the problem, but I've also put the number line over here so we can do things side by side. So the first interval we want to consider is before 2. In other words, x less than 2. We'll need a test value. So our test value, in this case, I'll use 0. That's a nice easy one. I'll do my substitution here. And remember, our inequality we're working with is t squared minus 5t plus 6 less than or equal to 0. So we substitute the 0 in there and check to see if we get a true or false statement. 6 less than or equal to 0 is false. So we're not interested in that interval before 2, because our test value of 0 gave us a false statement. Next, we need a test interval between 2 and 3. Let's try 2.5. So we're testing 2 less than x less than 3. And we'll try 2.5 there. So I plug that in, and I get negative decimal 25 less than or equal to 0. That is true. So this is our interval 2 less than x less than 3 here. We tested 2.5, and we got a true statement. Our last interval we have to consider is x greater than 3. So let's try 4 as a test value. That gives us 2 is less than or equal to 0, so that's false. So the only part of the number line that works is anything between 2 and 3. Now don't forget though, our inequality has an equal sign, so we can include x equals 2 and x equals 3. So the interval we actually need also includes the equal signs here. 2 less than or equal to x less than or equal to 3. We'll go back and put that on our original number line, and there is our solution. So the ball is at a height of at least 30 meters from t equals 2 seconds to t equals 3 seconds, including the 2 and the 3 seconds. In summary, 2 methods for solving a quadratic inequality are graphing the corresponding function and identifying the values of x for which the function lies on, above, or below the x-axis, depending on the inequality symbol. For inequalities with the greater than or equal to symbol or less than or equal to, include the x-intercepts of the corresponding function in the solution. If you are determining by using roots of the related equation, as we did in example 2, and using a number line and test points, then you include the roots of the corresponding equation in the solution set if there's an equal sign in the inequality.